Okay, so we are on day 2, solving systems of equations with substitution. Quick review. Systems of equations means more than one linear equation. Yesterday, we worked on graphing. We found the answer, the solution, to be the point where the lines either intersect, or if they are parallel lines, there's no solution, or if they coincided, they laid on top of each other, there's infinite solutions on the line. Did anyone find a problem with yesterday's work? What did you not like, or what did you like about graphing? If we look at yesterday's, was there anything that you liked or disliked about graphing?
I didn't like how if you didn't have the lines right, like you said yesterday, then it would give you a different number because I got one of my questions wrong for that. Good.
Yeah, see, that's exactly where I was. Even when I did you guys' homework so I could grade it with you, there was a couple when I looked at them like, is that point on that part? Is it not? Is my line off? Is it not? I wasn't sure of my answer. I love the ones that were like this. Y equals x minus 8. That's easy to graph. I like that. I didn't like the ones where it was like this and I had to do a bunch of work to work with fractions. So, there's times when graphing is going to work okay. Today, this is the one my algebra kids were kind of giving me grief on. This isn't their favorite, but we have to know all three of them. This is the one that some like a lot, some don't. I love this one. This is the one I use the majority of the time. It is substituting. So we've learned graphing. We're doing substituting. After we do the third method, what do you think I'll do after we've done 1, 2, and 3 methods? Good. We'll probably take a quiz over all 3 of them. So, here we go. Let's fill out our steps. Taking your notes with me. Please make sure you're following along and doing the notes, because we'll put this in your binder. So, it says, steps to solve, and we're using the substitution method. Step 1, solve one equation for, I'm going to say for y or for x. So I'm going to take my equation, whatever it is, and I'm going to solve it for y, like slope-intercept form. Or if you want to do x, you can solve for x. There's times when you're going to look at it and it's easier to solve for one of the others. Okay? Step 2. I'm going to switch colors so it seems easy. Substitute. I think this matches up with the method. Substitution. Substitute. That's the taking the notes with us. Substitute this expression into the other equation and solve for the variable. So let's pretend on step 1 I solved for y. I got y equals 7 minus x. Step 2, I'm going to go into the other equation. Since I said y equals 7 minus x, wherever there's a y, I'm going to take that y out and I'm going to put 7 minus x in. And then I'm going to solve for x. Step 3. You got to make sure I use the right words. You can say substitute. You can say replace. Replace your answer into the revised equation from step 1 and solve for the other one. Let's solve for the other variable. So it's going to be a little bit of work back and forth. Like I said, this is my go-to method. This is the one I love the best out of the 3. So the rest of the class, we're going to do a few examples, and then I'm going to turn you guys loose to use your time in class to do your homework. That way, if you have questions, I can help you here in class. So here's what we're going to do. First one, y equals 4x minus 1. Y equals 2x minus 5. If we were graphing, using method 1, we'd identify the slope of the y-intercept. We'd graph both lines, find where they intersect. Today we're substituting.
Are we not putting anything above the steps to solve?
No. It's like if you had any other notes or needed any other information. So, if I look at step 1, solve one of the equations. Do I really have to do any work on this? Do I have to do any work for step 1?
No.
They've already solved for y. I love those. I have to do no work at all. Y equals. So step 1 means I either want it to say y equals, or I want it to say x equals. Only one y, only one x. They've done this on number 1. So I'm going to use either one. Which one do we want to use? Do I want to use 4x minus 1 or 2x minus 5? There is no wrong answer. Okay, so here's how this is going to look. If y equals 4x minus 1, I'm going to look at step 2 and I'm going to substitute into the second equation. So here's y on the second equation. So when I go to write the second equation, I'm going to do it right up here and rewrite it. Y equals 2x minus 5. When I rewrite it, instead of saying y, I'm going to put in this 4x minus 1. And that should make sense. Yeah, we said y equals 4x minus 1. So if I say y equals, well, y is 4x minus 1. So I'm just going to put 4x minus 1 equals, and I'm going to finish my equation. 2x minus 5. That was step 2. Oh, I lied. That's part of step 2. That's the first part. The second part is now we have to solve the equation. So now, I only have one variable. X. Let's solve for x. Well, I got to get my x's to the same side. And what I'm going to do, my trick, this one was 4x and this was 2x. So I'm going to try moving my smaller one to the one that has the larger one. So I stay in the positives. So here's my equal sign. I'm going to subtract 2x from each side. When I do that, 4x minus 2x gives me 2x. I still have a minus 1. But 2x minus 2x, they cancel each other out, and I'm left with only negative 5. Alright, Eden, I'm going to pick on you. What do you think I would do next? If I have 2x minus 1 and it equals negative 5, what do I do next?
Add the 2 negatives. Or no, add 1 negative to the...
Alright, good. I'm going to add 1 negative to the other. I'm going to move the negative 1 over here. So I'm going to do the opposite. I'm going to add 1 because I want to get it away from my variable. So I have 2x. And then negative 5 plus, move this down, negative 5 plus 1 is negative 4. Okay? Now I have negative 2x minus 4, or negative 2x equals negative 4. Harrison?
You divide 2x by 2x.
Good. Now that I'm multiplying my coefficient and variable, I'm going to multiply or divide. X equals negative 2. Cool. So I'm going to go over here and I'm going to write this down right now. X equals negative 2. That was step 2. Step 3 says, now I'm going to replace my answer. I'm going to take that negative 2. X was negative 2. I'm going to take that negative 2 and I'm going to put it into my equation. And to be honest, I can put it in either equation. I can put it in the top one or the bottom one. I'm just going to do the top one. So the top equation was y equals 4x minus 1. So I'm going to say y equals 4, and it's 4x. So 4 times x. And what did we say x equals?
2. Negative 2.
Negative 2. Minus 1. So all I've done is copy down this equation. I took this equation right here. The reason I use it 4 and then parentheses 2, negative 2, that just shows multiplication. It's like distributive property, but only to 1. You'll typically see that in math because we don't use x for multiplying anymore. You can use that dot that hangs in the middle. But even then, mathematicians say it's easier just to do this because it shows that this was being replacing that x? It's a good question. Okay, so now I'm going to solve the equation. And usually when you solve the second one, it's a lot easier. Y equals, well, 4 times negative 2 is negative 8. And we still have a minus 1. Y equals negative 8 minus 1. Please get this right. Think.
-9.
Good. We have so much trouble with our integers. But negative 8 minus 1 is negative 9. I've now found x and y, so my answer is negative 2, negative 9. There's only one thing that we ever have to be careful of, and that is to make sure if we ever look to see a slope that they don't have the same slope. Because if they have the same slope, that's going to tell me my lines are either the same or parallel. But for today, we're going to worry just about substitution. So I'll do one more with you, then I'm going to have you work with a partner and work on like 3 and 4, and I'll come around and see how you're doing. So number 2, y equals 6x, 2x plus 3y equals negative 20. Step 1, does any of these solve for y or x already?
Yes.
Yeah. So I'm going to go ahead and highlight this. Since I noticed that y is 6x, anywhere you have a y, if I have a box that says y on it, when I open it up, it's going to have 6 times x in it. Every y is 6x. So I'm going to go to my second equation, and there's that y. I'm going to substitute my 6x, because I said y is 6x, so I'm going to substitute that in for y. This is our very beginning. So I'm going to say 2x plus 3, and typically we would say 3 times y, but we are substituting 6x in. All because the first equation told me that y was 6x. Okay. And I finished my equation. Equals negative 20. Let's solve. I still have 2x, positive number, so plus 3 times 6x equals 18x equals negative 20. Okay, I'm going to look for like terms. I have 2x and 18x. Oh, good. I have coefficients, the same variable. So I can add my coefficients. 2 plus 18 is 20x. 2x plus 18x, 20x, equals negative 20. Like Harrison told us on the last equation, when I have a coefficient in front of my variable, and that's all we have left, I have 20 times x, I'm going to divide. Divide by 20. Divide by 20. X equals negative 1. I'm going to go over here. X equals negative 1. Now, let's see if someone can tell me how to do this part. If x is negative 1, what do you think I should do? Kate?
Wouldn't you times 2 by negative 1 because it's 2x and x equals negative 1?
Where are you at?
Like for 2x plus 3y.
Oh, okay. So you want me to put this negative 1 in for the x?
Yes.
Perfect. I can do that. I'm going to stop you. We're okay. I can write this equation out. 2x plus 3y equals negative 20. And I'm going to put the negative 1 in for x and solve to make sure. Because then I have to make sure I get what y equals. Why do I not want to use 2x plus 3y equals negative 20? I can, but why? Well, it's not solved. Neither one of them is solved. Brett?
It's not
Well, we know y is 6x. This equation is a little easier though, right? You're absolutely right, and I'm going to show it just so you can make sure. But you see in between my two equations, y equals 6x, that's a lot easier than this one, right? It's only one step. So I'm going to choose to use that one. Y equals 6x. And I'm doing that because there's only one y, so I know I'm not going to have to do much work. Y equals 6 times, and we just said that x is a -1. So I'm going to solve that. Y equals, and 6 times -1 is -6. My answer, -1, -6. Alright, I'm going to show real fast. I'll just do the work. Kate's right. I could have done this. And that's the one nice thing. There is not a wrong method. It's just which one's easier. This would have became -2 plus 3y equals -20. Or added 2. I said 3y equals -18 divided by 3. Y equals -6. We still got the same answer, but this was one step where this was 1, 2, 3 steps. So let's just try to choose the one that's a little easier for yourself. Okay? We have a bunch of these. Woo. So here's what I'm going to do. We have 11 minutes left. I want you to try number 3 for me. I'm going to pause our video. I'm going to have you guys do it. What I'll do for you guys is I'll make this video, I'll finish the video in a little while, and I'll upload it, and I'll do the rest of the problems for you, okay? That way, if you get stuck in your homework tonight, you can come back to this lesson, and you can get any help that you need, that you can see how you use substitution. But I'm going to pause our video here, and I'm going to stop it. But what I want you to do, before I give you homework, I want you to try, well, what's the purpose? I mean, I might as well just give you the homework, right?
Yeah.
Okay. I'll tell you what I'll do. I'm going to give you your homework. I will finish the rest of the problems, okay?